So I've worked my way through the board. I've removed every transistor from the board one at a time, documented the device type, and I've tested it, and they all test okay. I thought for a moment I had a bad one, but it was a different pinout from the other devices. I've really gone through, like I said, all the transistors, they all test good. I've looked at all the diodes, there are several on the board, they all look good. I don't see any burnt resistors. It's possible this is a capacitor issue, though I'm kind of doubting it. I'm not seeing bulging caps or electrolyte leaking or anything like that. I'm kind of down maybe to this semiconductor device here. And I'm going to go ahead and unsolder it and remove it. This is a single-sided board, which makes things nice. Makes it very easy to unsolder stuff. Let me document here the orientation that's in. So it's behind these three pots. There's a heat sink fin on the back, and the screws are going through this direction. So I don't intend to remove it from the heat sink. Looks like the notch see, I'm looking at it from the bottom of the board. I'm looking through the board here, trying to think. The notch is towards these connectors. There's actually a notch there. Not that I can test that device, but I want to pull it out. Is that a bad solder joint? Take a closer look at that solder joint. I think I see it's not a really good solder joint there, but I think it's actually fine. Let's go ahead and remove him. Because this is a single-sided board, it actually makes this kind of work pretty easy. I got one pin that didn't release. I do. Let me add a dab of fresh solder to it, and we'll hit it again. The failure mode that was described to me is just suddenly the vertical collapsed. So UPC 1031H2. So the vertical yoke connects up here, and the vertical is what's out, and this is close enough to the vertical yoke that it's suspect. So the white band, again, is to the edge connector. Always good to keep lots of notes. And this is a UPC 1031H2. I don't know how easy it'll be to find a replacement or how expensive. It's an NEC device. And again, working on single-sided boards like this, the soldering tool works really well. As you can see, components just lift out very simply. If the part's inexpensive, I will order it and give it a shot. We can see in the something to point with here, whatever material they've used here to glue things down, this is pretty burnt and flaky around this device. So the device has definitely been hot. It's got a heat sink on it, so that's pretty obvious as well. Anyhow, and of course, putting a new device in is just, literally pinch through the hole, hold it in place, solder it back up. If I really think this is what I'm going to go at next. These tantalum capacitors could have issues. I really hate to work through this and remove every capacitor and test it. Again, just don't see any signs of electrolytic underneath the caps I can see in there. It doesn't mean these large ones haven't failed, especially this one, which is really close to the heatsink here for the horizontal drive. I don't know, just once again kind of doing a once over, looking at the tops of caps for anything that seems to be domed out. Oh, that's interesting right there. That could, why is there corrosion on the top of that cap? It may be from heat from that heat sink, that C652. The negative is marked in the silk screen. Always make sure. And the device is in the same orientation. I'm going to go ahead and pull him while I'm here, if I can identify the two leads. Nope. Got one of the leads, but not both. He's a little tricky in there. He doesn't look damaged. I'm going to resolder while I'm here the extra joint that I unsoldered accidentally, just so I don't miss it. (16-volt, 47 microfarad). It's the corrosion on the top of the package that makes it suspect. Where's my capacitance range? Though I should probably be looking at ESR perhaps, although he's a tiny cap. Let's just go ahead and do a gross capacitance measurement. Sorry, the meter's off screen. It's measuring 70 microfarads, which is way out of spec. Problem with my ESR meter is I blew the front end out in one of the ranges. I need to change the frequency up, I believe. Get it to work. Let's see what it thinks it is. It's measuring 36. Again, that's really low. I think it's the 1 kilohertz range I blew out. Or maybe it was the 10 kilohertz. It's measuring a little low. may dig for a replacement if I've got one here. It's a pretty common value. And go ahead and replace it. Probably doesn't show up on camera too well. There's just corrosion on the top that to me makes it a little suspect looking. And it's not going to hurt to replace it. You know, this guy here has been and these ones close to the heat sinks are the most suspect to me just because they are being heated. And while I'm here, I'll go ahead and pull him out. He is C720 or C732. This was a 47 microfarad, 16 volt. And this big guy is 10 microfarad, 25 volt. Wow. That's really a large cap to be. Oh, it's non-polarized. Which is probably why it's so large. Again, given its position on the board, I seriously doubt it failed. Because I think it's just a power supply smoothing cap, potentially. See if I can get the... Looks perfectly normal. I'm going to make a mark here. On the outside direction, it is non-polarized. Ten microfarads spot on. 10 microfarads spot on. 10 microfarads spot on. 10 microfarads spot on. 0.25 ohms. I thought I'd blown the front end out of this, but at the moment, in this very large cap, it seems to be working. You know, he's only 85 degrees, but he looks fine to me. I see no reason to think about replacing it. Get it tacked back in. Again, given the proximity or the location on the board so far away from the vertical drive, I suspect it's okay. These all should be discharged. Kind of a cheat to test from the back of the board. 490 microfarad, it's 470. 1 kilohertz, it's a little low. 10 kilohertz. Actually, I think we just passed through the range. Where I blew myself up. He seems reasonable. Let's come over to this guy. 508 microfarads, which is within expected range. this guy. Of course, can't read the label on him. 100 microfarad, 16 volts. It would help if I was on the right polarity. .96 microfarads. Yeah, the low range on this is toast. 98 microfarad. That looks like it's probably okay. And 45, he's probably a 47 microfarad. Flipping this board around to read stuff is so much fun. Where's the label? 47. There's a little 1 microfarad sitting here. I think is right here. If I can get the leads on. Get them to hold. Yeah, 1 microfarad. I've got a large bulk one over here, 2200. Sorry, the board's probably in the way of the meter. Again, the challenge is getting 2.2 millifarad. There's a couple of tantalums here. Come on, leads just aren't quite long enough. Oh, wonderful. Leads just aren't quite long enough. You know, you always need a millimeter more than you have. And 2.2 microfarad. And the other one is sitting down below it. Should be right here. These are an 88. Didn't see it. Oh. These are in 10 microfarad. All I'm here is going to be visualizing these because they're damn, you know, it's just nearly impossible to be able to tilt the board in a direction where you can see in there, and it really is impossible. Either everything's in shadow, read it. Actually looks like it's a house number and not that is really frustrating. Get on him again. Oh, come on. So, I've got a suspect capacitor with a bunch of corrosion on it that I think I'm going to go ahead and see if I have a replacement for here. I've looked at a few others and they seem to be okay. I didn't actually look at that one, or this one hidden back here. You know, kind of running out of stuff here to think beyond this IC, which I will go research. Hopefully it's not a $100 part. I don't see any damage to the package. Like where it's got hot and popped. Hard to say whether it's partially failed or not. Anyhow, I will end this segment here.